Okay, here's a little help on adding vectors. One of the things that you'll hear in your physics course that is always confusing is that you'll hear your professor say that a vector has no location. So it's just indicating a force and a direction. You can move the arrow anywhere you want, which is very strange. Now, eventually you'll have vector fields, and that won't be true. But it's just indicating the direction and size of a force. So imagine that you're in this scenario. You are V. You are walking in the direction of V at a certain mile per hour, okay? And then in addition, some strong wind blows in the direction of you. So these are just two separate forces that are both acting on you. That's why they don't essentially have a position. So what you have to understand is that if you just if you just did the force of V and then added the force of U to it, that's where you would end up being pushed. Does that make sense? So then in order to represent U plus V, sorry, you would have to say, okay, where would I end up if V and U both acted on me? And it would be right there. Does that make sense? So this teal vector is U plus V, but also recognize that U plus V is the same thing as, well, what if I just stood still and let the wind push me first and then I walked? I know that's not how it would really work, but then that would be V plus U. Well, I should hold on. Let me undo that. Let me go back to this. Here would be your V, and then if I wanted to do U plus V, it would be just in the same direction. So in this question, to represent U plus V, sorry. You would pick this one. Okay? Hope that helps. Boom.